everyone, it's time for us to start talking about summarization in the context of EIGRP. EIGRP is one of those protocols that we're going to be working with that allows us to perform summarization just about anywhere we want to be able to do it. And the configuration is done in the context of our interfaces. Now, the main thing that I want to drive home here is the fact that summarization allows me to do administrative style traffic engineering, and it also affords me the opportunity of being able to reduce the overall size of my routing table when it comes to learning prefixes. So the net effect is I can use summarization to be able to actually advertise a network that's reachable in my infrastructure that actually embraces several more specific addresses. So what I'm going to do is I'm going to take a look at how we are going to do a configuration in this environment. And we need to recognize, first of all, that we have two different types of devices. And by types, I'm talking about how they're configured. EIGRP Classic mode is running on R22. So we're operating in classic EIGRP configuration on R22. On R1, we're using named operation. Now, what I want to do is I'm going to create a series of prefixes that I'm going to represent in my routing domain using EIGRP, and I'm going to create address 100, loopback 100, all the way to loopback 107. And we're going to advertise these, first of all, on R22 in the range of 22.22.0.0 all the way down to 22.22.7.0. Now, when we look at this, this is the form that that's going to take. So I'm going to dive over here on R22, and I want to one moment. What I'm going to do here on this particular device is just illustrate the fact that we have these interfaces. I went ahead and just recreated them, or actually created them from scratch. So show IP interface brief exclude assigned addresses, and we see these four addresses, or I'm sorry, these 8 loopbacks running the networks that I described in the original portion of our discussions. So now what I want to do is I want to advertise these. So what I'm going to do is I'm going to say config T router EIGRP 10, and I'm going to say network 22.0.0.0, and I'm going to advertise everything. Show IP EIGRP interface is going to tell me that these are all being advertised. So now, if I got all my sums right, I should be able to have reachability on R1. Now, routes that we've discussed on R1 that have been advertised to R22 have been reachable through load sharing. Now, the cool part here is that means prefixes that I advertise on R22 are going to be learned across my two different devices, come down and meet at R1, which means I'm going to still be able to do load balancing. So what we'll do now is I go to R1. On the confines of R1, I can type show IP route. And what I'm going to see here is I'm going to see that those prefixes are indeed reachable, and I'm going to load share. Let's use a trace route just to verify that. So trace route 22.22.0.22, and you can see very clearly that we are in fact load sharing. Now, the main idea here is that by virtue of the way that I've got the system set up, what I want to do right now is I want to experiment with a way to be able to do some traffic engineering. So let's look at this scenario. I'm going to grab my green pen, and I'm going to recognize the fact that, well, first of all, let's use a yellow pen and talk about how these routes are being propagated. These prefixes are actually being advertised to R2 and to R3, from R2 to SW1 over to R1, and then from R3 down to SW2 over to R1. So I'm sorry, SW1 on the left-hand side there. So that means that when I do my load sharing, what I'm going to do is I'm going to load share across these links. Now, what I want to do is I want to modify this behavior. What I want is I want a scenario whereby my system is going to prefer to send packets using the second interface here on R22. So what it's going to be is it's going to be serial 2/1, where the top one here is serial 2/0. So the way I'm going to be able to do that is I want to affect how R22 is going to originate these prefixes. And what I'm going to do is I'm going to send the more specific /24s out to 1, and I'm going to send a modified summary address out of S20. So let's take a look at what that would be, what that involves. So on R22, what I'm going to do is I'm going to select interface serial 20, and I'm going to say IP summary dash address EIGRP 10, and I want to summarize the 22.22 networks down to where I can represent all of these in a single network. So what I'm doing here is I'm going to be taking the fact that I'm going to be running from 0 all the way down to 7, which means I have 7 consecutive networks numerically, but concatenally, remember, we're counting from 0, so that means I have 8. So if I take 256 and I subtract 8 from it, that's going to give me the range that I want to use in my configuration command. So right now what it's going to be is I'm going to say 225 wants to match exactly, 225 wants to match exactly, and then what I'm going to say is I'm going to say 248 here, and that should allow me to advertise my configuration. So again, if I add this up, if I added 8 to 248, then obviously that's going to give me 256. So looking at this, let's see what happens. Well, this contiguous mask is not supported. What am I doing? Oh, 255, 248.0. Still 255. Oh, man, I got typos all over here. I apologize. So it's 255.255.248.0. Now it should take it. So now when I come over here and look at R1 and I repeat my trace route, what I'm going to find is I'm no longer load sharing. That's going to be the behavior that I expect, to stop doing the load sharing, because what's happening is let's look at our routing table. Show IP route EIGRP, and let's take a look and see what we've got. Can I embrace all of these in one screen? Yes, I can. So I'm going to go from 22.0.0.0/8 all the way down to 22.22.7.0/24. And let's look at these. I'm going to take myself off. And notice, I am learning a /21 prefix. The /21 prefix I'm learning is coming into R1 through Ethernet 0, 0. So that's going to be through this interface. So in order for it to get to here, it had to come from here. So what I'm doing is I'm advertising that /21 down this link, and R1 is going to prefer to reach any of those prefixes via the link through R2 on S serial 2/1, because these are going to be configured with /24 prefixes. And keep in mind, longest match is always going to be the trump. So no matter how I learn a prefix, irregardless of which protocol I learn it through, EIGRP, RIP, OSPF, whatever protocol we're talking about, the longest match is going to be the one that I'm going to use. So right now I'm advertising the same prefixes or the same networks on R22 out 2 interfaces, but what I've done is I've opted to summarize those that are being advertised out of S2/0. Now S2/0 is going to propagate those down. S2/1 is going to propagate the /24s. The /24s are going to be used to reach all of our individual destinations. And again, we can verify this. Let me grab my eraser here. We can verify this again using that trace route. So if I do my trace route to 22, notice it's going to go straight through. Let's pick another one. Let's say I want to go to 7.22. So as we can see, I did 0 all the way down to 7.22. Now what that does is it illustrates the fact that we could use summarizations and have used summarization for the purposes of load sharing, but that's not really load sharing. In this scenario, if I were to go to R22 and go to interface serial 2/1 and shut that interface down, and then go back over to R1 and repeat my trace, what I'm going to find here is that it stops. Notice it's not working. So I have 10.1.201.12. So it's trying to go through the same trace as before, Now, this is a little misleading. It looks like it fiddled around a little bit, about 6 seconds, and then all of a sudden it worked. So let's see if we can't repeat this trace. And what we're going to see is it does work, but it's taking the different path. It's going through Cat 1, R2, down to R22. So by virtue of the fact the way this is designed, if I lose one of these links, I still have the capability of having reachability, because then what I'm going to do is I'm going to default to the /21 because I have no /24s in my table. Let's take a look at that. Show IP route, EIGRP, and we'll look at what we've got, and we'll find a single entry that is a /21 for 22.0.0.0, which means we're learning that summary, and notice it's coming in specifically from Ethernet 00. Let me get out of the way, Ethernet 00. So with that being said, let's bring that interface back up and let us do a little bit more testing from the point of view of doing this on R22. So exit, no exit, I don't want to no shut. Let's see if everything comes back up. We'll go over to R1, show IP route EIGRP, and let's see if we now have the reachability. We don't yet. There they are. So we have our summary at the top, and then all of the others that are being learned by Fast Ethernet 01 on the other list. So what I'm going to do is I'm going to remove that summary, and we're going to take ourselves back to where we were before. So I'm going to go to interface 20, and I'm going to say no IP summary address, and I'm going to use the right address this time. And then let's take a look and see what's happening on R1. Ultimately, we should load share against all of these prefixes, which is what's happening. And if I come up here and show IP route 22.0, 22.22.0.0, 255.248.0, I have no entry in my routing table anymore. So in other words, I've withdrawn my summary prefix. Now, let's take a look at something else that may have happened over here on R22. Show IP route. Well, we're running a summary. So let's see what we've got here. So the question is, I'm actually doing summarization on this particular device. So here are my links that I have. These are all going to be my connected interfaces. These are the loopbacks. And when we look at how the device has been set up, what I want to do is I want to pay attention to the fact that we're generating this summary. So show IP route, it'd be 22.22.0.0, let's just use it and see what's in here. So right now we just have the connected /24. Let's see what we have. 255.248.0 and see what we see. Not in the routing table. So the idea here is we're generating this prefix and we're sending it out, but I stop that process. So show run interface S20. There's no command there, nor is there a command on SW1, so I'm not generating the summary. So by taking all this syntax off, I've merely removed or suppressed this idea of summarization, which means now from R2, if I do my test, I'm going to load share again, which is what I would actually expect to do. So right now, let's go in and change this scenario. I said that we were going to do everything on the basis of learning scenarios or scenario-based learning. So before I look at anything else, I want to change the way this topology is operating. So let's get rid of, I'll go ahead and just get rid of the majority of this. What I want to do now is I want to set it up to where, let's say I want where this is going to be scenario 2. Scenario 1 is I wanted to pick SW1 over SW0. Now what I want to be able to do is I want to say I want any addresses from 22.22.0.0 all the way down to 3.0. I want those to be reachable via S21. Now that means the second part of this is that anything from 22.22.4.0 to .7.0, I want to be reachable via S22. 0. So what I'm going to do is I'm going to say, well, if I want to use S21 to have reachability, I'm going to advertise the summary out S20. If I want S20 to be what I use to reach 4.4.0.2.7.0, I'm going to advertise that out of 20. So here's the way we'll make this work. I'll go to R22, config T, interface summary, interface serial 2/0. So in this scenario, I'm going to advertise the summaries for 22.22.0.22 all the way, or 0/24, all the way down to .3.0/24. So how do I do that? Well, what I'm going to do is I'm going to say IP summary address EIGRP 10. And now that I've done that, what I want to do is I want to specify the address that I want to summarize. So I want to summarize 22.22.0.0, but I want to go from .0 to .1 to .2 to .3. So I've been able to increment that. That means I need to manipulate the third octet here, this third value, the one that right here where my finger's pointing for the 0. So that means this one's going to stay the same, this one's going to stay the same. And now what I want to do is I only want to count from 4 starting from 0. So in order to be able to do that, I'll say 256 minus 4 gives me 252, hit .0, and plug through. So now I'm going to resynchronize. I'm going to come back up. Why? Because my summary configuration has changed. And what we'll do now is let's do the matching configuration or the marrying configuration to S21. So now what I want to do is I need to go and advertise the next 4 networks. So from 4.0 to 7.0. So I'll say IP summary EIGRP 10. And what I'm going to do now is I'm going to say 22.22 dot, which one am I going to use? I'm going to start counting at .4.0. And now what I want to say is I want to count down 4 prefixes. So I'm going to start 4, 5, 6, and 7. And I'll do that by saying 255, 255.252.0. So again, I'm going to count down 4 networks. 256 minus 254 is 4. So 252 is the number that I'm going to use here in this field right here, and then hit enter. So the only thing that changes is where I started my incrementation from. So I'm going to see what's going on now. So let's cut over to R1 and say show IP route, and let's take a look at this and see what we have. Notice I have two summaries. Notice I have a /22 that I'm learning from 0, 0. I'll take myself out of the equation here, and I have a /22 that I'm learning from 0, 1. So now let's look at this. This means that if I got my sums right, I should be able to do a trace route to 22.22.0.22, and based on our expectations, this should traverse R2. So let's hit it and see what happens. Well, here's what's going on. Notice it's going up. Let's see, how did I do this? 21. Should it traverse R3? I was looking right here when I should have been looking here. So I said I wanted to use S2/1 for information or for packets to arrive to these 4 networks. And what we can see here is exactly the case. It's going from .24, which is SW2. From SW2, it's going up to R3. From R3, it's going down. So in order to reach 22.22.0.22, I'm using SW or S2/1. So let's verify this. We'll go through and go through each of these and see what happens. So let's see if we can trace route to 1.22. Notice it's traversing R3. We'll go to 2.22. It's traversing R3. We can see that right here. And then lastly, let's do 22.3.22. Still traversing 3. So now if we got everything right, according to what we said we wanted to have happen, we should use S2/0 for anything going from 4.0 to 7.0, which means we should be traversing R2. SW or S2/0 points to R2. So let's see what's happening. So once again, we'll use the trace route for testing, and this time I'm going to say 4, and what we're going to find is it's going to traverse R2. Again, we'll just repeat this to make sure that everything is uniform across the board. So we'll say 5, traversing R2, 6, traversing R2, and 7, traversing R2. Now there's one other thing that I want to do here inside the context of classic configuration, and that is I'm going to create a new loopback. I'm going to create loopback 08 on R22, and let's see what happens. So we'll go over to R22, enter config T, interface LO 108, IP address 222.222, 8.222.255.255.255.0, and it should automatically participate in my protocol. Do show run section EIGRP, and we'll see. I'll go ahead and take this chicken scratch off. We see that my network command says run anything that has 22 in the first octet, and I can verify that even further with the do show IP protocols command. And what we're going to see here is the fact that 2222, I'm routing for it. I could also say show IP EIGRP interface, and now we'll see 108 down here. So there's many ways that I can use to verify if and when I'm actually applying my protocol. But the question now is, what happens on R1? What will R1 have in its routing table as reachability information to get to that prefix? So first of all, is it reachable? Ping 22.22.8.22, it is reachable. Can we trace route to 22.22.8.22? And we're load sharing. Why are we load sharing? Well, we're load sharing because the third octet is 8. So in this scenario, we have a situation where we're saying the first octet 255 has to match. So it's always going to be 22. Second octet 255 matches. So it's always going to be 22. So these are constants. So they're always going to be 22.22. Now what we're going to do is this third octet is where we went through and we made some manipulations. We said 252. Now if we look at 252, what we're saying here is that I already said that we're going to be incrementing by 8. But the question is what adds up to 252? Well, let's look at this in binary. So what I'm going to do is I'm going to come over here and I'm going to write this out in binary, and you're going to have to excuse my writing skills. So when we look at this, I'm going to say, first of all, I have in the third octet all zeros. 1, 2, 3, 4, 5, 6, 7, 8. So it's 2, I'll just do part and decimal, 222.222, sorry, wasn't paying attention. I'll write it out one more time. We're going to have 22.22. Now what I'm going to do is I'm going to convert this next part to binary. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then I'm not really caring about the fourth octet. So what we're going to look at is the first octet. So when I go through here, my next one is going to be 0, 0, 0, 0, 0, 0, 1. So that's going to be 0.0. This one will be 1.0, where these numbers are 22, 22, 22, 22.1. Then it's going to be 0, 0, 0, 0, 0, 0, 1, 0 for 2.0. And then lastly, what it's going to be 1, 1, and then all zeros. Now all I'm doing is doing binary math. So if we look at this, what ends up happening here is that I draw an ordinal number line. I mean, I told you guys in the very first set of videos that I do this on almost every test I ever take. I don't care if it's CCNA, I don't care if it's CCNP, I draw an ordinal number line. That number line is going to have two pieces of information in it. So it's going to be a number line. It's going to have 8 points on it. 1, 2, 3, 4, 5, 6, 7, 8. Now those numbers are going to be representative of different values. So the first one is going to be 128. Then it's going to be 64, 32, 16, 8, 4, 2, and 1. The other values are going to be 128, 192, 224, 240, 248, 252, 254, and 255. Now, what I'm doing here is that I'm going to take the ordinal number line and I'm going to compare it to our matching digits. So what's going to happen here is that this first field matches, so it's all zeros. This one matches, it's all zeros. As does this one, this one, this one, and this one. Now, everywhere from this point to the right can vary. So those are not the ones that I'm going to worry about. So what I do is I count 1, 2, 3, 4, 5, 6 columns. 1, 2, 3, 4, 5, 6. And that's the number that I use in order to be able to advertise my prefix, 252. If I needed to do 8, we saw earlier, if I did all my binary math, I would have to match on this one, which meant I was using 248. So this allows me to advertise 4 prefixes. This one allows me to advertise 8 prefixes. If I needed to summarize even further, I could use 240. So again, this is just going to be the binary mathematical component that allows me to be able to manipulate the prefixes that I'm going to be advertising using summarization. And we're going to repeat this concept throughout every writing protocol that we're going to talk about, because summarization or aggregation is going to be a critical part of all of our configurations. Now what I'm going to do is I'm going to snip this particular portion of our presentation, and then what we're going to do is we're going to go to R1. In fact, I'll bring back my drawing. We're going to go to R1, which is operating in named mode, and I want to look at how we're going to summarize, or how we can summarize prefixes going towards the rest of our network. So we're just going to reverse our point of view. What we're going to do is we're going to generate prefixes on R1, advertise them, and we're going to look at them on R22 in the data center. I'll see you guys in that part of our presentation. Bye-bye.